Okay, so what we have done till the last video is uh, I had to abruptly stop it because OBS died on me for some reason. So this is another recording. It's going to continue to sort of draw a triangle in OpenGL. So I think what we reached to creating a shader program in the last video. So let's continue on from that. Okay, so mm, what a shader program actually is, like in my understanding, what I think it means is it's sort of a container that consists of the compiled versions of both the vertex shader and the fragment shader, and it passes that on for the usage to be able to sort of uh, to be able to use it in the final product, like the final image, how it is being used to be able to pass those data. So that is what a GL shader program is. It's sort of a neatly packed box inside which those compiled vertex shaders and fragment shader exists. So that's sort of what's being explained out here, I think. And assigned, this is how you do create a GL program is through GL create program. And after that, you need to attach those vertex shaders and fragment shaders. And in OpenGL, you do that through GL attach shader function. So let's do it in our code as well. GL attach shaders. So GL attach shader. I think it's shader. The first parameter is the shader program. So that's our variable shader program. The second parameter is the compiled shader that needs to be passed. It's most probably just the memory address that's being passed, but that's important. So pass the first, we need to pass vertex shader, so we do that. Second, we pass the shader program, fragment fragment shader. Okay, so after that, we also need to link the program, link the shader program to. I know it's currently bounded for the GPU, so we need to link the program to the GPU and see if the GPU accepts it. I don't know, I just feel like I'm making stuff up, but I intuitively think that's what's going on. I've not actually looked into details, so I don't know. I guess it, that's what I think. I don't know. I might be wrong. Most probably I'm wrong, but it sort of works. So I don't know. After that, we link the program, GL link program, and pass the shader to that. What we also need to do after that is check if the program linked successfully or not. We can use that using the same checking function we have out here. That is fragment shader. Okay, so where the fragment shader could not compile. Everything else is correct. So let's just copy this bit of code out here. Check link success. Control Y. Okay, so let's change the variable names out here a bit. Mm, Okay, so another thing is, since this is not a shader, it's a program, so I need to change that to a program B, and also need to change the first parameter to shader program because it's program and not compile status, but we're checking a link status, so GL link status, and everything after that is sort of a shader program. So full of two program could not be linked would be the correct error prompt. Program could not After that, once we have created and linked and attached the shaders and linked the program, we also need to specify that we intend to use the program, and how we do that is through GL use program. So let's do that. Sort of telling we are currently bounded to use this program. So uh, what's the correct terminology? Activate program. Activate program. GL use program. So the first is shader program. Okay. After that, every shader and render will know. Okay, that's it. Okay, so what comes after that is after you've used those vertex and fragment shaders, you also need to delete them. Uh, I guess I don't know. Mm, since till now, what I've seen is, and I've not seen much, but what I've seen is normally I have seen like only a single vertex shader and fragment shader program sort of used. Like I've, you can so I think you can use multiple vertex and fragment shaders and compile them accordingly and use them. But I've sort of what I've encountered is mostly a single vertex and fragment shaders are being used. So and normally they are deleted or terminated at sort of the end side of the program. But I think normally you can use them. Maybe we found out later on. Okay, let's just delete them out here in the end. Delete shaders. Okay. Delete shader. First parameter is vertex shader. Second parameter would be fragment shader. Fragment shader. Okay. And mm, before heading on to the next section, let's see if that terminates. Let's clear it a bit. It's a bit messy. Slash run. Okay, it seems to be working fine. So let's move on to the next part, that is linking vertex attributes. So this part I think is uh, everything is sort of important in OpenGL, but this is a little bit more important in the sense, and this is I think the sort of linking bridge between like how you need to manipulate, how the data needs to be correctly manipulated and accessed, like how the data needs to be used by the GPU, like the info that's being transferred. That's what this enables us to do. So let's see what this is saying out here. Just to specify this. Okay, we need to manually specify what part of it, which vertex attribute and vertex shader. We need to manually specify how OpenGL should interpret the vertex data before rendering. Uh, let's just sort of begin understanding this through this line, GL vertex attribute pointer. So now, how should I start this? What? Uh, so you have a vertex buffer that you pass on to the GPU. Like the vertex buffer consists of that array, like the vertices that you have passed. Yes. So that vertex buffer consists of these values. So these are the positions, vertex positions for the triangle. So now what what problem arises is that since like you know that it's like you have divided it like in a 3 into 3 row sort of inside a vertex, and you know like for each point you need it needs to have a 3 points, but uh, the GPU doesn't know that. Like the computer, not even GPU, like the computer does not know how it needs to process this data, like at what intervals it needs to access this, and how many numbers it needs to access it at a single time. So to bridge that gap, vertex attribute pointer is used. Like you can see the diagram out here. So just see, like it consists of three vertex. Normally we need three vertex to draw a triangle. Each vertex consists of three floating point values, which is of uh, which is of single floating point value is of size 4 bytes. So total it consists of 12 bytes. A single vertex consists of 12 bytes, and we have three of those. So just increment is like that, and this is how the memory. This is how the number is stored in the memory. Like sequentially, these values are stored like that inside it. So how do we like first access only the three elements, then go to the next three, then go to the next three, with these three being the first vertex points, while these three being the second vertices points, and the last three being the third ones. So how we use that, how we do that is through the vertex attribute pointer. The first, okay, so let's begin. Let's sort of see the parameter to be able to understand it better. So what the first parameter specifies is that, okay, what is trying to say? Remember when we wrote in the vertex shader, like layout location equals to 0 in vec3 position. So what this first parameter says is that map the values that are in that vertex buffer in that buffer to the location that is present out here. You see the location is set to 0 and the first parameter is also set to 0. This means that whatever value is present in that vertex buffer in that position, like just pass it to this location in the vertex shader in sort of a vec3 value. Vec3 means three floating point values in positions. So only the first three positions is going to be passed from the layout location 0. So how we specify how many numbers and what type of values is to be passed is through the next parameters. The second parameter is how many arguments, how many vertex values do we need to pass. Like since we need 3 points, we are going to specify it as 3. Third is the type of vertex attribute. No, not the pointer. The third is the type of uh, vertex values data that is to be passed. That's the GL float. And the fourth is like if the data is to be normalized or not. So normalization is like shrinking down the vector into a unit vector that's like a range between 0 to 1. So we are not going to do that. So we specify that as GL false. The third is the size, the total size. So what the third is, like this is the stride. Stride is basically like an offset like position for the next vertex. Like just what I intuitively understand out of this is what is written out here is 3 into size of float. So since a float consists of 4 bytes, and since we have three floating point numbers in a single vertex, so 3 into 4 is 12. So after 12 bytes, jump to the next, just like point to the next vertex, point to the next like memory location that's 12 bytes away. So after we incrementally do that till vertex 3, we no longer have to do it because we have specified to do it only 3 times. So we traverse the vertex points 3 times while accessing all the points of the vertex inside it. So that's sort of how I understood it. If you sort of have uh, confusion, then you can sort of ask again, and I'll sort of try to provide a better explanation. But is how I sort of understood it. So, and the last parameter is Currently, sort of don't need to know what the last par- uh, if you sort of understand the stride, then you can easily get the last parameter. So it's also sort of an offset, but uh, currently you don't actually need it. So if you understand stride good enough, you'll be easily able to understand this, and it's going to be used later on. So at that time it's going to be explained properly. I'll explain it properly later on. Currently you don't need it, so let's leave it at what it is. And after that, you need to enable the vertex attribute position, at what location the pointer is to be passed. So that's 0. So that's it. And uh, okay, so normally vertex attribute pointers are specified at the end of the shaders. So let's do that. Vertex buffer object. I think it's below vertex buffer. Yeah, I think here. Setting of vertex attribute pointer. Attribute pointer. Attribute GL vertex attribute pointer. The first parameter is, as we have said, the location. Location that's also specified in the vertex shader where we need to pass our data. So that's 0. And how many data will we need to pass? 3. That's 3 points at a time. The data type is of GL float. Fourth is GL false, that's the normalized. And fifth is the size of each vertex. That's 3 into size of float. And the fourth is we don't need it right now, so let's just specify this at void pointer 0. We also need to enable that's GL vertex attribute. Is it array or is it pointer? It's array. Trip array. Okay, so I think that's true. Trip array enable vertex attribute. And after that, okay, hold on, we have to do that. So after that comes the vertex array objects. So what vertex array object is that, imagine like those buffer objects like vertex buffers as sort of a small box consisting of all those vertex attributes. Now imagine a vertex array object is a bigger box. So the vertex buffer is placed inside the vertex array object like a bigger box. What the vertex this bigger box also can contain is those vertex attribute pointers we just discussed. It can also consist of those. So VAOs consists of many VBOs and like vertex attribute pointers. Like it does not contain in the sense like it can sort of contain a lot of attribute pointers given from what the diagram says. Like I sort of have an intuitive understanding of it, but this diagram sort of confused me at the beginning. Uh, so to my understanding, what I think is that a VAO can consist of one or two, I don't know, many vertex buffer objects and many vertex attribute objects, but at a single time, only a single vertex buffer objects can be used by all the attribute pointers, and many attribute VBO can a single VBO can be used, and many attribute pointers can be used. Uh, cannot be used concurrently at the same time. V2 VBOs cannot be used by a single VBO at the same time, but two VBOs can be used by two VOs. So that's that. And normally in OpenGL, you need to specify a VAO, generate a VAO before you can draw anything. I don't know. Maybe in the past could have drawn just using the VBO, but I think there was sort of a manual process. But currently, this is how it's done. So how we generate the VO is that it's sort of an intuitive process till now. What we pass the first parameter, we generate the VO using GL vertex arrays. The first parameter is nothing more than how many VOs we want to generate. That's just it. Just pass the VO as parameter. Let's do that. Normally VOs are initialized at the beginning, like above the vertex buffers, where the buffer objects, vertex buffers are generated. So let's do it out here. Vertex sign int VO GL gen vertex array one at the rate of VO. Okay. So after that, we also need to define the vertex array. How we do that is sort of an intuitive statement: GL bind vertex array, GL bind vertex array, VO, and I guess that's it. Yeah, I guess that's it. So now we can sort. We are sort of ready to draw a triangle. Okay, so let's specify the last bit of things we need to do before we draw a triangle. First, we need to specify that we need to use the correct shader program. We use that using GL use program, program, shader program. And after that, GL, we need to specify what the vertex array object that we are going to use. We specify that using GL use vertex, GL, I think it's GL bind vertex array. It's the first VO. Then we use the function GL draw triangles. GL draw triangles. I think it's triangles. Oh nah, it's GL arrays. GL or arrays, and the first parameter is to pass. We pass GL triangles. We can. There are many different parameters you could pass, but since we are sort of drawing a triangles which consists of three vertices, then sort of use it. The second parameter is just the beginning indices we are using to draw, sort of saying to leave it at 0. So let's do that. The third is the number of vertices we are going to do. We are going to draw, that's 3. So let's specify it as 3. GRIA, GL triangle 0, 3. And now we should be able to draw our triangle. Let's see. Spell mistake. GL gen vertex arrays. Fix that. Okay. After that, GL triangles. Triangles. It's triangles. TRIAN. Okay, let's see if we can draw a triangle. Okay, yeah. So this is it. This is the triangle that we have been waiting for. Mm, let's sort of. I've sort of changed the value, so I know the color of the triangle is sort of different. So let me just see what the fragment shader is saying out here. The value should be 1, 0.5, 0.2. Let's change it out here. Let's compile it again. Okay, so yeah, this is it. This is our first triangle using OpenGL. It sort of took a while, but this is how sort of images are drawn in OpenGL, and uh, there's still some more stuff to do, and I guess we're going to do that next. But yeah, today this is what we have today. A triangle looks pretty good. It's orangey, looks good. Okay, so yeah, this is it for today.